All right, first thing, hopefully we remember about tangent, is it is a ratio of trig functions. What is tangent a ratio of?
Trig functions.
Which, that was a good one. Which two trig functions? Sine and cosine. Which one goes on top? Sine or cosine? Sine. Okay, so tangent, yes, tangent is equal to, and I am going to color code these. So we're going to do, let's do sine is red. I'm going to do sine of red, and then I'm going to do cosine on the bottom. Okay, if you remember from your unit circle, okay, if I was looking at like the tangent of this point right here, actually let's just do the tangent of pi over 4. If we remember the coordinate of that point, the coordinate of that point is the square root of 2 over 2, comma, the square root of 2 over 2, right? So if I'm finding the tangent of pi over 4, well, I'm taking the y value and dividing by the x value. So I end up getting 1, right? So the tangent of pi over 4 is equal to 1. Okay, that will come back into play here very soon. But what I want to do first is I want us to write out the XY charts for sine and cosine, and then I'll show you how our ratios kind of come to play, because again, we are going to have some asymptotes on here just like we did for our reciprocal functions of sine and cosine. So I'm going to write here sine of theta, x and y values. So your same 5 coordinates. And then same thing for cosine. Okay, so I'm going to give you a minute, see if you can't remember which values go in there for your y value. And then I'll write them up here in a second. All right, do we agree with my sine and cosine y values up there? Sine starts at 0, 0. Cosine starts at 0, 1 and makes their full period length. Okay, so then if I'm looking at tangent, I'm going to write my x, my y's again. My same 5 values. And now to find my y value, I'm going to do this ratio of sine over cosine. So I'm looking at the y values of sine, and I'm dividing those by the y values of cosine to find out what my tangent value is. Does that make sense? Okay. So I'm going to take 0 from sine, and I'm going to divide by 1 from y. And if I take 0 and if I divide by 1, what do I get? 0. Okay, next one. If I take 1 and I divide by 0, what is 1 divided by 0? Undefined. Okay, which means if it's undefined, what are we going to have at those values? Asymptotes, okay? At pi, I'm going to take 0 and divide by -1. What do I get? 0. At 3 pi over 2, I have -1 divided by 0. That gives me undefined. And then lastly, 2 pi, I take 0 and if I divide by 1, I end up with 0. Okay, so at those values of pi over 2 and 3 pi over 2, I'm going to have vertical asymptotes. Okay, so let's start out by drawing and labeling my x-axis. Every 2, I will go by pi over 2. Okay, so at 0, at pi, and at 2 pi, I'm going to have vertical asymptotes there. Okay, let me backtrack here. I'm at pi over 2 and 3 pi over 2. Thanks for catching that. Okay, does that look better? Very good. Okay. So similar to cosecant and secant, all I really care about is you being able to like kind of show me where the shape is, like so where that U-shaped parabola is going. For tangent and cotangent, what I care about is you showing me where these lines are going to go for my curves, because we know they're going to approach the vertical asymptote, so they're never going to cross it. So we need to figure out, is it going to go up? Is it going to go down? What's going to happen? So I'm going to show you why, and then you guys can just remember what it looks like, and that's fine. Okay, but let's say I pick a point in between 0 and pi over 2. Let's pick like pi over 4, because we already evaluated that, right? What was tangent of pi over 4? 1, right? We just found that up here. So tangent of pi over 4, I'm going to call this 1 right here. I would have a point right there, which means this curve is actually going up towards that vertical asymptote. Okay, if I went in the other direction, if I went negative pi over 4, think about on your unit circle here, negative pi over 4 would just be down here. If I wanted to find the tangent of that value, I'm going to have a positive and then a negative, right, of those square root of 2's over 2's. So what would my value be at negative pi over 4 for tangent? Is it 1 or negative 1? It would be negative, right, because negative y over a positive x would give me a negative 1 value. So our shape is going to be kind of what looks like a cubic function, okay? So in between pi over 2 and 3 pi over 2, we said tangent of pi was 0. You're going to have the same exact shape. It's going to go up to the right and down to the left. And then at 2 pi it was also 0, so it's going down to the left and up to the right. And again, technically these values are at 1 and negative 1. But all I want you guys, all you have to have drawn on your tangent and cotangent graph is where it is crossing your midline. Because again, this is not always going to be, it's not always going to cross the x-axis. It could be shifted up or shifted down. But I need at least 1 point to show me where your graph is going, up or down, okay? Now, we got to talk about period in this case, because the period, remember for like sine and cosine, sine, your graph looks something like this. Starts at 0, 0, and it goes like this. Once I get from 0 to 2 pi, I repeat my cycle, right? So our period length for sine is 2 pi. Same thing with cosine. Cosine starts at 1, and I've got my shape here. But then if I have another period, right, it goes through the cycle every 2 pi units for the parent function, or it could be changed depending on if your period's shrunk or not. But sine and cosine's period is 2 pi. Same thing with the reciprocal functions, okay? If I look at tangent here, how many or what, at what value is it going to repeat the same graph? How long is the period for this case? Just pi, right? I go from pi over 2 to 3 pi over 2. That's my whole graph, and then I repeat it again, starting at 3 pi over 2. I repeat the graph. So your length for your period for tangent is going to be just a length of pi, okay? Because remember, your period is how often does it repeat, right? It repeats every pi amount, okay? My domain is a little easier than my range to think about, so let's think about my range values, all the y values that I could possibly have. How would I write that? Negative infinity to, you got it. And then the domain part, I'm going to write it kind of funky, but basically all the domain part says is that x cannot be anywhere where I have an asymptote, right? So I can't have an x value of pi over 2 or 3 pi over 2 or 5 pi over 2, or same thing going in the negative direction, so negative pi over 2, negative 3 pi over 2, etc., etc. So I'm going to say the domain is x is a real number where x does not equal my pi over 2 plus or minus some n value times pi, where n has to be what kind of number? Do you remember from last time? An integer, okay, which we show with a z and then like an extra little line there. Okay, so again, that's your integer notation. And this just again means belongs to the set of. It's like a C with a little line in it. Okay, but what I want you to know is that you can't have x values where your vertical asymptotes are. You will not have to write it out this fancy on your test, okay? And really, the only questions that they will ask you are going to be about your range. So like, what is your range value? For tangent and cotangent, it's always going to be that negative infinity to infinity. But if it was like the cosecant or sine and cosine, those will change depending on what your amplitude and vertical shifts are, okay? Questions on the tangent function? Okay, so cotangent is exactly the reciprocal of tangent. So instead of it being sine over cosine, it's going to be cosine over sine. Which means if we think about that on the graph, right? If I have my normal tangent function goes up to the right, what do we think my cotangent function is going to do? Down to the right, up to the left, okay? So let's go ahead and write my cotangent table so we can figure out where my vertical asymptotes are going to go, because they won't be in the exact same spot. Okay, I apologize for it being kind of small, but instead of going back and forth every single time here, we're just gonna have it like this for right now. So cotangent, we're gonna go my cosine y value over my sine y value. So I've got 1 divided by 0. 1 divided by 0 gives me undefined. So this is gonna be undefined. Go back to my chart here. 0 divided by 1 is gonna give me 0. If I continue that pattern, what's going to happen for pi? Undefined, and then 3 pi over 2 would give me 0, followed by an undefined function. Okay, so now I can go ahead and plot my x-axis. So I've started at 0. And then where it says undefined, that's where I'm going to have my vertical asymptotes. So now I'll draw them correctly this time. I'm going to do them at 0, at pi, and at 2 pi. And I've got 2 points from my table up there that tell me I'm going to have points at pi over 2, 0, and 3 pi over 2. Okay, again, if I think about like an in-between point, pi over 4, we said that the tangent of pi over 4 was equal to 1, right? So what's the reciprocal cotangent pi over 4 going to equal? Wait, if it was equal to 1 for tangent, and I flip that, I'm still going to end up with 1, right? So I'm still going to have a value here at 1 for pi over 4. And if I evaluate in between, 3 pi over 4 for cotangent actually gives me a -1 value. Okay? So I'm going up to the left, down to the right. All I actually have to have on the graph, or what you guys need to have on the graph, is this point right here, and then the arrows drawn in the correct order. Okay? Bless you. So then at 3 pi over 2, same thing. I'm going up to the left, down to the right. And then how many periods do I have shown up there on my graph? 2 of them, right? Because again, our period length is what is it? How often does it repeat? It repeats every length of pi. So my period is still going to stay pi for this. My range is going to also stay the same of negative infinity to infinity. My domain is just where it's going to change, right? Because now instead of it being every pi over 2 plus pi, I'm going to start at 0 and then add pi or subtract pi every single time. So it's going to look something like this, where my x value is a real number. Actually, I wrote that wrong. Hold on. X is a real number is what I wanted to write first. X is a real number where x does not equal some number n times pi, where n belongs to the set of integers. Okay, fancy way of saying every length of pi, we're going to have a vertical asymptote there unless there is a shift of some sort. Okay, other thing to keep in mind if I zoom back out here a little bit. Okay, tangent and cotangent are reciprocals of each other, but they're technically just shifted and negative versions of each other, okay? I could rewrite a tangent function to look just like a cotangent function with some certain transformations applied to it, okay? So just keep that in mind. Same thing with sine and cosine. You could have 2 equations that give you the same exact graph, but they are 2 different functions, okay? Does that kind of make sense? Yeah, okay. Any questions on the parent function of tangent and cotangent? All I need to see is your vertical asymptotes and that midpoint and the correct shape. So up to the right or up to the left, okay? All right. Okay, few typos in here that I want to add. So the kind of change here for these ones is that we do need to figure out where our vertical asymptotes are going to be. So I think the easiest way to do it is kind of just setting up these 2 equations, but we need a plus c in here for all of these technically. So you're taking all of the stuff inside the parentheses for your tangent and cotangent function, and then setting them equal to these 2 vertical asymptotes, and then solving to figure out where those are going to go. Okay, because again, there might be shifts happening here or stretches and things, and we have to adjust that on our graph. Okay, then from there, you're going to find the midpoint of where your vertical asymptotes are. You're going to plot that point that's on your midline, and then you're going to figure out which direction your curve is going to go. The only other difference here between everything else that we've been doing is that to find your length of period, it's going to be pi divided by b, because my length of my period is not 2 pi anymore, it's just pi, okay? So your b value is still that thing in front of your x. So this is your b value here for this case, okay? So I've got a tangent function, bless you. So I'm going to set this equal to letter a here. So the stuff inside is 2x. And I'm going to set this equal to negative pi over 2 and pi over 2. Okay, now if you go back and look at your tangent parent function there, you are going to see that you have that vertical asymptote at pi over 2 and then again at 3 pi over 2. This is just a little less math to have to do if you just do the positive and negative side instead of also doing 3 pi over 2. Okay, but you could technically do 3 pi over 2 and set it equal to and solve as well. But if I solve this, I get x equals negative pi over 4 and x equals positive pi over 4. We okay with that solving there? Okay. So now on my graph, I'm going to plot my negative pi over 4, positive pi over 4, okay, and then at those 2 values, that's where I'm going to have my vertical asymptote. And now all we need to do is we need to find the exact point in between negative pi over 4 and pi over 4, which is going to be 0. And we were not shifting up or down at all, so my midline is still going to be my x-axis. And then we've got a tangent function. So is that going to go up to the right or down to the right?
Up to the right.
Up to the right. So I am going to approach both vertical asymptotes, but not cross them. Okay. Another thing we can check to make sure that we did correctly is that this distance is my period. So my period length here is technically pi over 2, right? Because negative pi over 4 to pi over 4 is pi over 2. Which I can also find by taking your formula and doing pi divided by b. And my b in this case is also 2. So pi over 2. Our period is actually pi over 2 when we graph our vertical asymptotes, so that means we did that correctly. And that is all we need to do. Unless it said to graph 2 periods, I could either go to the left or go to the right, but I would need to graph one more period if it said to do so. And I would make this distance pi over 2 in between there, which would make this, let's see, this would be 2 pi over 4. So that would be 3 pi over 4 for my next vertical asymptote. And I could draw my point in between there and just sketch my graph. Okay. So that's 2 periods long if it said that it needed to be that distance. Okay. Bless you. Questions on that? Okay. Moving on to the next one here. This one we're going to cotangent. So I've got 1/2 cotangent of 2x. Okay, cotangent we are setting equal to part B here. We're setting that equal to 0 and pi. So the stuff on the inside of 2x is going to be set equal to 0 and pi. And if I solve these, I get 0 and pi over 2. So that tells me where my vertical asymptotes are going to be. So we've got vertical asymptote at 0, vertical asymptote at pi over 2. If we were just doing 1 period long, that's all I would need. If I want 2 periods, I would need to go further down to pi. Now I've got 2 full periods here. Again, distance between your vertical asymptotes, that's your length of period. So your period length is pi divided by 2, which we can double check in our formula here because that's my b value. So pi divided by 2, that is true. That is what we should have gotten. So then I pick my point in between. So in between 0 and pi over 2, there's a point here, pi over 4. And it is a cotangent function. So are we going to go up to the right or down to the right for cotangent? Down to the right. So I'm going to approach my vertical asymptotes there. And I can draw another one in between pi over 2 and pi. And then the only thing that we really didn't do anything about is this 1/2. What does that 1/2 technically do to my graph? It shrinks it, right? So technically our coordinate points of 1 over, this should technically be at like 1 here and -1 here. So if I was shrinking that, what would my new point technically be at? If normally my point's at 1 in between, it would technically be at 1/2, right? So this point right here is technically like at 1/2 instead and 1/2 instead, but I don't care about seeing those exact points. So your amplitude is really not going to affect, or at least to the eye, it's not going to affect your sketch of the graph. Does that make sense? So all I care about is you showing me your correct period length and then your correct direction of your curve. Last one here. Okay, let's talk about what all these transformations are going to do before we actually set and find our vertical asymptotes. What is this -2 going to do out front here? Down 2. Okay. Let's take this kind of one step at a time. What does cotangent look like? Am I going up to the right or down to the right? down to the right. But then I have this negative in front of it. What is that negative in front of it going to do? It's going to flip it. So this is actually going to become a graph that looks like this. We're flipping that over the x-axis. Okay? So that's our end function graph looking like. And then now we've done all three of those things, or two of those things, and now I can set this stuff inside equal to my two asymptotes. So this is a cotangent one again, so I'm going to set this equal to 0, and I'm going to set this equal to pi. And if I solve both of these, I get x equals pi over 4, and then pi plus pi over 4, what's that going to give me? 5 pi over 4. Okay, so let's graph those x values on here. So I'm going to go every 2 is a pi over 4 value. And always make sure you simplify your fractions on your x-axis there. And then I can draw my vertical asymptotes on there. And then the next thing we got to look at is what's exactly in between pi over 4 and 5 pi over 4. What's halfway in between that? The 3 pi over 4. However, is my midline the x-axis in this case? No, it's being shifted down to, right? So down, I'm going to call this 1 and 2. So this is now at -2 here. So I have like that midline is now here. So my point that I'm actually going to plot is not going to be at 3 pi over 4 comma 0. It'll be at 3 pi over 4 comma -2. So that's the only point that I would be looking for on the graph other than your labels. But then the other thing is I need to see which direction it goes. So we talked about what our end function is going to look like. So we know it's going to go up to the right with that transformation of that negative, and then down to the left. We can double check our length of our period. This distance in between pi over 4 and 5 pi over 4 is a length of pi, right? And if I check my function here, my period is pi divided by b, where my b value is 1. So pi does in fact equal pi. So we are good there. My graph shape looks right. So that is all I would need. Okay. Questions on that? Okay. It is 11:45. We've still got plenty of time left in class. So I'm going to give you guys about 15 minutes right now. If you want to go back and look over cosine, sine, secant, and cosecant graphs and things, that might be a good idea. And then we'll do our quiz in about 15, and then the rest of class time will be work time. Sound good?